Today, we're going to dive into a technology that makes a really bold, almost magical promise, especially for anyone who's ever had to build a distributed system.
No, really, just stop and think about that for a second. What if all the time you spend building in fallbacks, retry logic, and complex recovery plans could just go away? What if failure just wasn't your problem anymore?
Look, this is the one universal truth we all live by in software. It's never a matter of if things are going to break, it's always a matter of when. You know the drill. Networks get flaky, a service you depend on goes down, a deployment goes sideways. It is the chaos we are all constantly building around.
And trying to deal with this reality, it often feels like we're stuck in a trap. Instead of building cool new features, we spend all our time just putting out fires, reacting to the fragility of the very systems we're trying to build.
This probably all sounds painfully familiar, right? It's the daily grind for so many developers. You're constantly firefighting. You're writing these incredibly brittle state machines that break if you look at them wrong. There's just endless boilerplate code for every edge case, and when something does go wrong, it needs someone to manually go in and fix it. And the worst part? The user's progress is just gone. It's totally exhausting.
And this quote just nails it. This shouldn't be the default state of our jobs. There has to be a better way than just lurching from one inevitable failure to the next.
So how do we actually escape this trap? Well, this is where Temporal comes in. And it's not just another library or framework. It's a totally different way of thinking about the problem, and it's built on a concept called durable execution.
Now, let's be super clear. Temporal doesn't magically stop APIs from failing or networks from crashing. It starts with the assumption that, yep, failures are going to happen. The real magic is that it makes those failures completely irrelevant to the progress of your application's logic.
So what on earth is durable execution? Honestly, the best way to think about it is like a save game for your code. At every single step of your logic, Temporal is automatically saving the complete state. All your local variables, where you are in the code, everything. So if a server crashes or a service is down for hours, it doesn't matter. Once things are back online, your code just picks up from the exact point it left off as if nothing ever happened.
Okay, so that sounds great, but how does it actually work under the hood? Well, it's based on this really elegant idea of separating your code into two types: the logic that means to be invincible and the actions that have to interact with the messy, failure-prone outside world.
Here's the core difference. In a traditional app, all your state lives in memory. If that process dies, poof, the state is gone. With Temporal, the state of your core logic is actually managed and saved by the Temporal service itself. A crash isn't a catastrophe anymore. It's just a pause. The code just recovers and keeps going.
So the first piece of this puzzle is what's called a workflow. This is where you write your main business logic, the step-by-step process for an e-commerce order or a user signing up. You just write it like normal code, and Temporal automatically makes it durable. It can survive anything.
The second piece is the activity. Now, this is any interaction with the outside world. Think API calls, database updates, sending an email, all the stuff that can and will fail. Temporal knows these are the risky parts, so it wraps them up with automatic retries, timeouts, and error handling, completely shielding your durable workflow from all that chaos.
So let's just walk through it. Your workflow is running its logic. It gets to a point where it needs to call an external service, so it calls an activity. Uh-oh, that activity fails, network error. Does your whole application crash? Nope. Temporal just catches it and automatically retries the activity according to the rules you set. Once it finally succeeds, the result is sent back, and your workflow continues from that exact spot, like the failure never even happened.
Now, I know this might sound like a really cool computer science concept, but this is not some academic toy. This was built from the ground up to solve massive, real-world problems.
And you can see that just by looking at where it's used. We're talking everything from complex AI pipelines to massive e-commerce order fulfillment systems. It's used for processes that have to run reliably for days, weeks, or even months without ever losing their state. This is for the heavy-duty, mission-critical stuff.
I love this comparison from Guillermo Rauch. Just think about how much React changed front-end development. It gave us a whole new, declarative way to think about UI state. This quote is saying Temporal is doing that same massive shift, but for the backend. It's a fundamentally better model for managing state and logic.
And for every engineering leader out there thinking, we could probably just build this ourselves, well, this quote from the co-founder of HashiCorp is pretty telling. Getting durable execution right is an incredibly hard problem. Temporal has already solved it and battle-tested it at scale.
And that kind of reliability doesn't just appear out of thin air. This technology has some serious pedigree. We're talking about a system that's been battle-tested for almost a decade, built by the very same people who created large-scale workflow systems at AWS and Azure. And on top of all that, it's 100% open source with a huge active community.
So let's bring it all the way back to the beginning. Remember all that stuff? The constant firefighting, the brittle state machines, the manual recovery. With a platform like this, that's just not your problem anymore.
You actually get to focus on what matters, your core business logic, and build applications that are, for all practical purposes, invincible to all the transient failures that used to keep you up at night.
And that's really the question to leave you with. It just opens up so many doors. If you could just assume your code would always eventually run to completion, what new, complex, and ambitious things could you create? What huge problems could you finally solve that always seemed way too risky before?